Hello, today we are going to talk about patterns and equations, called 15.4. And to show you these, we have some tables, so we're going to dive right in. You may have seen these and you may also know them as in and out boxes. What these boxes use are patterns to solve for each variable. So if you look up here, we have x values and we have y values. And so what this is saying is when x equals 2, y is going to equal 14. When x equals 4, y equals 28. When x equals 6, y equals 42, and so on. With these tables, our job is to figure out what our rule is. So how are we going from x to y? Write that in an equation. And then also we have some missing boxes here and here. Using our rule and using our equation, we have to figure out what numbers go into these missing boxes. So, first thing we're going to do is figure out what our rule is. Basically, we're figuring out how are we going from x to y. How are we going from 2 to 14, 4 to 28, 6 to 42? Once we figure that out, we can write an equation, and then we can use that equation to find our x value and our missing y value. So I always like to think and look at my numbers. So you start with x. So my first x value is 2. I always think to myself, to go from 2 to 14, am I increasing or am I decreasing? If I'm increasing, I know that I am either using the operations of adding or multiplying. If I'm decreasing, I know that I'm either using division or subtraction. So here, I'm increasing 2 to 14. To go from 2 to 14, I can add by 12, or I can multiply by 7. My next one, I can't just stop there. My next one, going from 4 to 28, I'm increasing. If I increase with addition, I can add, I'm either adding 24 or I'm multiplying by 7. I'm starting to notice a pattern here. Okay, my next one, 6 to 42. To go from 6 to 42, I'm either adding 36 or I'm multiplying by 7. I need to pick the rule that is the same for all of my values. So to go from 2 to 14, 4 to 28, 6 to 42, I can see that I am multiplying by 7. The 7 is consistent or the same with all of those numbers. So my rule is to multiply by 7. Now, my equation is pretty simple. I'm always starting with x, and I am multiplying my x times 7. And so instead of doing another x from a symbol, I'm just going to put my 7 in parentheses, because I know that when I have a variable or a number next to something in parentheses, it means multiplication. And since it's an equation, I need an equal sign. My x times 7 is always going to equal my y. My x and my y are my two variables that are consistent. They don't change. The only thing I insert is my rule. Now, I can use my equation to solve for this missing y and this missing x box. Now, my y, let's solve for y first, up here. I know that in that equation, my x equals 8. So I'm going to take my equation that I came up with, and all I'm doing is plugging in my 8 for my x. So I have 8 times 7 equals y. Well, I know that 8 times 7 is 56. And there it is. So when x equals 8, y is going to equal 56. Same thing for my missing x x. I can use the same equation that I came up with, but instead of plugging in 8 for x, I'm going to plug in 70 for y. So let's look. I'm going to say x times 7 equals 70. Using my inverse operation, I know that I'm going to divide by 7 on each side to get the x by itself. 7 divided by 7, those are going to cancel. All I'm left with is x. 70 divided by 7 equals 10. So x, up at the top up here, equals 10. And I can check that by coming back to my rule and saying, is 10 times 7 equal to 70? It is. Okay, let's try another one. All right, so for this one, when x is 0, y is 16. When x is 20, y is 36. When x is 36, y is 52. And I don't know, I have a missing, when x is 42, y is something, but I'm not sure what it is. The first thing I'm going to do is come up with a rule. So what I always think, am I increasing or decreasing? Well, to go from 0 to 16, I am adding 16. I can't multiply by anything because 0 times anything is still 0. So I don't have a 0. Let's check over here. 20 to 36, I'm increasing, so I can go up by 16. 20 times 1 is 20. 20 times 2 is 40. So 20 times nothing is going to be 36. 36 to 52, I am increasing by adding 16. And 36 times 1 is 36. 36 times 2 is 72. So I can't multiply by anything here either. So I know that my rule has to be adding 16. Now to come up with my equation, I'm always starting with x. I'm inserting what my rule is. So my rule is plus 16, and it always equals y. There's my equation. And then to solve for y, I know that 42 is equal to x. So instead of writing x, I'm going to write 42 plus 16 equals y. 42 plus 16 equals 58. So x plus 16, 42 plus 16 equals 58. Okay? Let's do another one. All right. Here we go. We have x when x equals 6, y equals 2. When x equals 12, y equals 4. When x equals 24, y equals 8. And then we're missing this x right here. We're not sure what that is yet. First thing, I need to figure out if I'm increasing or decreasing. Well, to go from 6 to 2, I'm decreasing. So I can either subtract 4 or 6 divided by 3. Okay? 12 to 4, I'm decreasing. I can either do 12 minus 8 or 12 divided by 3. And 24 to 8, I can either subtract 16 or I can divide by 3. The dividing by 3 is the same in all of these, so I know that my rule must be to divide by 3. To write my equation, I'm starting with x. I'm inserting my rule, which is divide by 3, equals y. And then to figure out what my missing number is down here. I'm taking my equation and plugging in my variable that I know. I know that y equals 11. So if I take my equation, I've got x divided by 3 equals 11. Using my inverse operation, I know the inverse of division is multiplication, so I'm going to multiply by 3 on both sides. When I do that, my 3's cancel. I'm left with x. 11 times 3 is 33. So I can take my 33 and I can plug it in right here. To double check, I can take 33 divided by 3. 33 divided by 3 is 11, and that's what I get right here. All right, last one. We've got when x equals 12, y equals 6. When x is 10, y is 4. When x is 8, we don't know yet. When x is 13, y is 7. And we are missing our x here. Y is 13. All right, my rule, either increasing or decreasing. To go from 12 to 6, I can either minus, subtract 6, or I can divide by 2. Okay, to go from 10 to 4, I can subtract 6. And I can't divide 10 by anything to get 4 evenly. 13 to 7, I can subtract 6. And I also can't divide anything by 13 to get 7. So the same thing, what's constant is this minus 6. So my rule must be to subtract 6. My equation, I'm always starting with x. X minus 6 equals y. And then to solve my x and my y variables, I'm taking my equation, inserting my known variable to find my x and my y. So we'll do y first. I'm not sure what it is, but I know that x equals 8. 8 minus 6 equals y. 8 minus 6 is 2. So 2 must equal y in that one. And let's solve for x. I don't know what my x is. X minus 6 equals, my y equals 13. Now, to get x by itself, I need to use my inverse operation. The inverse, or the opposite of subtracting 6, is adding 6. So I must do that to both sides. My 6's will cancel out. And my 13 plus 6 is 19. I'm going to come back up to my table and write my 19 up here. I also want to make sure that I double check. 19 minus 6 equals 13. And it does.